Hello everyone. Today we are on board to present a topic called battery management system. This video series is presented by myself Manikanta, Ekta Parikshit and Avinash. So whenever we talk about the battery management system, first we will see why a battery monitoring system is required. So coming to the battery monitoring system, this battery, we know that the battery monitoring system consists of a series of lithium ion cells having different voltages across their terminals. These tiny cells are connected in parallel and series combination. These tiny cells are very dumb and highly unstable. The voltage across the cells has to be precisely monitored and balanced. If we don't do so, then we won't be able to come up with the battery pack, and destroying the battery pack will be the ultimate thing. In this, as we are going to discuss about the electric vehicle, if we are not doing this in respect to this, so when a battery is charging, we have to apply the voltage and current to it. If this voltage is more than the specified limit mentioned in the data sheet, then it is considered that the battery is charging with over voltage, which will eventually increase the temperature of the battery. Every battery has a specific range of temperature in which the temperature in which the battery works fine. So this temperature increases, which ends up in reducing the state of charge. This condition also increases the internal resistance of the battery and eventually the power loss across the battery increases. On the other hand, if the voltage applied in the battery is lower than the also it lead to over temperature. Over voltage and under voltage lead to a temperature which degrades the battery life, and if we use battery at a temperature lower than its specific range, then its capacity decreases. Due to this, the old temperature, the batteries might catch up with fire, as well as there is always slight differences in the state of charge and the charge rate capacity impedance between two cells, even if the cells are from same manufacturer and produced in the same lot. While charging or discharging these cells altogether, some cells experience a lot of stress in the battery pack, so they lead to degradation. Well, to avoid all these scenarios, we must have to monitor over voltage and under voltage limit of the battery. We have to keep a close watch on battery temperature, and we have to ensure that the charge level of each battery stays within the recommended range by balancing every cell so the efficient in effective way. Here first comes the discharge control. Batteries healthy first is the discharge control. The primary goal of a BMS is to keep the battery away from operating out of its safety zone. The BMS must protect this during the discharge. And the second comes the SOC determination. In this, the user about to current capacity of the battery can be known, and the battery, there are several methods to determine the SOC of, so that the SOC can be determined through two ways, the direct voltage measurement and coulomb counting, and the third way is the combination of coulomb counting and voltage measurement. Well, there are different types of determination of SOC methods, but we will be focusing mainly on the first two. In this, the discharge cycle of the battery is associated, the battery voltage decreases, the battery also decreases in the Coulomb counting method, and the current coming in or going out of the battery is measured over time to calculate the relative amount of charge. It's like pouring water into a pot. The pouring water tank and it's fetching out to imagine the battery as a jar and water is like electrical energy or charge. The BMS measures how much current is going inside the battery and calculates the charge deposited inside the battery over the time. When the calculated charge is near to the rated capacity of the battery, then the BMS informs that the battery is fully charged, and while it is charging, it follows the same process in addition to the both methods. The third combination one is the Coulomb combination of Coulomb counting and voltage measurement. In this, we will be approaching both the methods, and the next one comes the SOH determination. The state of health is the basic thing where we need to measure the health capacity of a battery when compared to the new one. Any physical parameter of the battery, such as internal resistance or conductance, changes significantly. The internal resistance of the cell depends on the impedance. As battery internal resistance of the battery increases, next comes the cell balancing. Cell balancing is a method to compensate the weaker cells by equalizing the charge on all the cells in the chain to extend the overall battery pack's life. In the whole battery pack, small differences between the cells are due to the tolerance of operating conditions gives rise to uncertainties during charging. Weak cells may get overstressed and become even weaker until they eventually fail, which causes the whole pack to fail prematurely. So to avoid this, BMS has to provide cell balancing. Balancing BMS also works as a logbook because the SOH of a battery is relative term. It compares the new and old battery. So this measurement should hold a record of the initial conditions of a cell and should able to compare with the same cell as it gets old. So the logbook function is the most important, and then the communication BMS provides the information about the health SOC along with much more details of service and maintenance. In general, user who is driving the vehicle is not a technical guy, so the information should be simple and interpretable. On the other hand, the BMS technician is or an engineer is a highly technical guy, and he should understand each and everything regarding the BMS, and safety of the battery. Well, there are different types of topologies of a BMS hardware. It shows how we can connect these cells with a BMS first. The distributed topology, in this topology, there are small voltage and discharge monitor circuits which communicate with the master controller of the BMS. The advantages of this design is simple and reliable to implement, and as a highly reliability, the disadvantage of the system is it requires a large number of small PCBs and becomes difficult to mount on every cell. Next is the modular structure, and in this multiple slave VMs controllers are used to face the data and forward it to the master controller. So no special PCBs are necessary in this. And next comes the centralized topology, and it is a master unit is directly connected to each cell of the battery pack, and the controller unit protects the and balances all the cells. Using this topology decreases the hardware, but excess heat could be generated because the controller is the only source for cell balancing in centralized topology. Next comes the battery management system. It is made of many hardware and software functional blocks, which are the CFET, DFET, and fuel gauge circuit, cell voltage monitor, cell voltage balancing, and the technology behind each block is the cutoff FETs. In this, the technology basically transistors, mostly MOSFETs are used. MOSFETs are nothing but the control switches. These are used for connections and isolations of the battery pack between the load and the charger. Switches these FETs. These can be configured as here it is a single connection to the charger and load. In our case, motor controller, and generally first configuration is used for charging where just one bus control the initially both MOSFETs are turned off. When a charger is connected, flowing both FETs off. BMS sends the voltage as the input, then it turns the CFET. If the voltage or input in is not present, and it turns on the CFET, which charges the battery. If the voltage at the input pin is not present, then BMS determines that motor is connected. This block keeps the track of charge coming in and going out of the battery pack. For measuring the current, a current sense amplifier and a MCU which has an analog to digital converter is used. A very low current sense resistor is connected in series. The voltage drop across this resistor is measured by this amplifier, then it amplifies the signal. The microcontroller measures the voltage and calculates the charge according to the time. The discharging and charging current is sensed by the direction of current. If the current is coming inside or going outside, that means the battery is charging, or there are certain fuel gas ICs are available in the market which takes care of the SOC, and many times using a fuel gas IC add additional cost to the BMS. In case of electric vehicle, using a shunt resistor is always the best option. The fuel gas, next comes the cell balancing. Generally, lithium-ion batteries are used in EVs. The voltage of a lithium-ion battery ranges from 2.5 to 4.2 volts, and it depends on the battery chemistry. As we saw last time, operating the battery outside the environment reaches the most lifetime. These cells are connected in series or in parallel. The nominal voltage and temperature imbalance will slightly uh, vary, differ from each other. So this weak cell heats up and its lifetime gets reduces. The weaker cell trips the discharge limit first, leaving the rest of the remaining cells charging remaining inside the same. This can be overcome by cell balancing. This cell balancing is derived into two parts. The first one is the passive cell balancing, and the second one is the active cell balancing. In this method, a dummy load like a resistor is used to discharge and equalize it with other cells. These resistors are known as bypass resistors. Each cell connected in series in a pack will have to undergo a MOSFET connected across. The weaker cell is turned on, the charge of this cell is removed and dissipated. This process minimizes the charging rate of the weaker cell. Whenever charge goes, the weak cell tends to go near to its full capacity. The MOSFET is turned on. So all the cells along with the weaker cells charges at the same time, but this method is not useful. The weaker cell may reach to its minimum cutoff voltage earlier than the other cell, but is not easy because it is very efficient, because electrical energy is dissipated as heat and has switching losses. Another drawback is that the entire discharge current flows through the MOSFET, which is mostly built into the controller IC, and hence the discharge current has the lower value to the IC's limit, which increases the discharging time. Active balancing, unlike passive balancing, is active. In active balancing, the excess charge from one cell is transferred to another cell which has low charge. So this can be done by charge storing components like capacitors, inductors. Well, there are many methods to perform this. Let's discuss the method which is commonly used. The charge shuttles or flying capacitor is the most commonly used method. In this, the capacitors are used to transfer the charge from high voltage cell to low voltage cell. The capacitor is connected through SPDT switches. Initially, the switch connects the capacitor to the cell which has high voltage, and once the capacitor is charged, then the switch connects into the cell which has lower voltage and the charge from the voltage to the cell. These capacitors are called as the flying capacitors. Well, the problem with this method is that the charge can be transferred only between them. Also, still it is better than passive. Just like there are many active cells balancing techniques, which are one of this is this one. Next important parameter is the temperature monitoring. Lithium-ion batteries provide a lot of current. So while maintaining a constant voltage, which can lead to a thermal runaway, causes the battery to catch up fire. The construction of battery is highly volatile. Well, this temperature measurement is just the temperature of the battery is suitable for charging these batteries, and the temperature sensors are used in general. The thermistor is basically a temperature dependent resistance. Whenever there is a change in temperature, the BMS calculates the temperature rise accordingly. As we saw, the BMS acts as a logbook to calculate the state of health and parameters of the battery. So for that purpose, the BMS has to take the data time, so it should be working even if the vehicle is not on run. Excess power from the battery pack itself. So to avoid that, a real-time clock is integrated, which needs a small power, and it does the job. Well, that's all about the battery management system of an electric vehicle.